Hello and welcome to New Scientist Weekly, where we discuss the most fascinating science news of the week. I'm Penny Sarche.
And I'm Rowan Hooper. Today we're going to talk about why there's no such thing as memory, not at least as we currently understand it.
Wow, and we're also looking at the most important biochemical process ever invented by evolution and how that's changing as a result of climate change.
We're going to start with the ongoing attack on science by the Trump administration. We're going to talk about the threat to NASA mostly, but I also want to talk first about Johns Hopkins University. This week it lost $800 million in grants. What's happened is the Trump administration has ordered this review into USAID. That's the US Agency for International Development. The review's complete, and they've decided that 83% of its programs will be closed, and that includes this $800 million that goes to Johns Hopkins. To get an idea of the importance of this institution, for 40 years running, Johns Hopkins has spent more on R&D than all the other US universities.
Wow. And so these cuts then, they impact grants at the School of Public Health Centre for Communication Programmes, the School of Medicine. It means projects all over the world are grinding to a halt. So that's including work to reduce the use of lead cooking utensils in Bangladesh, right through to things like improving agricultural productivity in the Democratic Republic of the Congo.
Yeah, work on malaria, family planning and reproductive health, education and nutrition in places like Tanzania, Uganda, the Philippines. Yeah, as you say, all over the world, all that's being stopped. And even if much of this work is nearly complete, it's just being stopped at the last hurdle. It means you'll get no more mosquito nets to protect children in Mozambique and other places, no chlorine tablets to purify water in Bangladesh. It means many people are going to die as a result of these cuts. And in the US too, there's going to be an impact on public health. In Baltimore, for example, they'll stop programs to support breastfeeding, for example.
Really tough to hear about. And then there's similar chaos at NASA, with the news this week that the space agency has closed its Office of the Chief Scientist, its Office of Technology, Policy and Strategy, and a branch of its Office of Diversity and Equal Opportunity. And today we've got news editor Jacob Aaron here. Jacob, what do we know about what's happening at NASA?
Yeah, so you mentioned the Office of Technology, Policy and Strategy being closed. That includes the roles of Chief Technologist and Chief Economist for the whole of NASA. Those are now gone. And we spoke with an employee there who had just been fired, and they explained how the office helps with strategic planning across the agency. For example, we've seen a recent uptick in moon missions. There's been a bunch of private missions going to the moon from the US, and part of this office's job was to make sure those missions don't interfere with each other. If you're looking at landing on the moon, operating around it, one issue is that we've got a lot of interest in the lunar South Pole, and there's concerns about having spacecraft operating near each other or wanting to cram into the same place. And the person we spoke to is concerned that these missions kicking up dust could coat solar panels on other vehicles, and they say these issues won't be tackled moving forwards.
These cuts are expected to be just the start of much larger cuts planned at NASA. What about the rumours then that NASA's overall science budget could be cut by as much as 50%?
So this would be really significant. These cuts would hit NASA's Science Mission Directorate Office. It handles all of the agency's scientific operations and currently has a budget of around $7.5 billion out of NASA's total $25 billion. And it covers pretty much everything that NASA does that doesn't include crewed spaceflight. So we spoke to Casey Dreyer of the US advocacy group, the Planetary Society. He says that cutting the budget in half would be a profoundly brutal consequence that would symbolise the nation turning its back on the cosmos. And he says it could result in many missions cancelled. So missions that are in their prime currently, like the James Webb Space Telescope, would probably be survived, but at risk would be missions either in the early stages of planning or ones that are later in their life. This could include climate satellites, the famous Hubble Space Telescope, the Perseverance and Curiosity rovers currently on Mars, and even the Voyager missions, which launched in the 70s and were the first spacecraft to ever leave the solar system.
Not the Voyager mission.
They're still going. You know, NASA still manages them, but if it cuts its budget, it's going to be looking at what it can stop doing.
I mean, it is an existential risk for a lot of NASA activities, isn't it?
Dreyer believes so. He says the impact on NASA could be permanent. If you completely destroy the pipeline of people, you have a significant and long-lasting consequence, he says. It is an extinction-level event.
What about the Artemis missions to the moon? Because they're quite far along, aren't they? And then the less far along missions to Mars.
Yes, so I think Artemis is more likely to survive given it was set up under the first Trump administration, and, you know, the visual of returning humans to the moon is going to be a huge display of US strength, and you can see that appealing to the Trump administration. Elon Musk, who is also playing a key role in the administration with his DOGE task force, he also stands to benefit from Artemis with SpaceX's Starship part of the lunar plans. As for Mars, I mean, I don't think anyone ever thought that it was likely to happen in the next 4 years. Trump has made positive noises about a crewed mission to Mars, but I don't think these cuts necessarily change anything because they probably weren't going to happen soon anyway.
Is there any chance then that this sort of DOGE Trump push might be reversed in some way, or the cuts aren't quite as widespread as we're hearing?
Well, I think the fact that they are specifically going after the science part of NASA rather than the crewed spaceflight part of NASA shows that, you know, we've seen elsewhere the kind of anti-science agenda that you were talking about earlier from the Trump administration. I don't know if they will back down, but a letter this week from Zoe Lofgren, who is the top Democrat on the House Science, Space and Technology Committee, urged NASA to fight back against the cuts. She said, DOGE will seek to slash and burn core functions of NASA. It is imperative that you stand up for NASA's critical work. So there are people who want to push back against this, but a scientist who is familiar with NASA's policy decisions, speaking to us anonymously, said that these cuts still need to be approved by Congress, so it is possible that they might not go ahead. They point out that NASA is really beloved on a bipartisan basis, but if the cuts did go ahead, it would essentially be the end of NASA science. No mission will be safe, they said.
Now, okay, as we know only too well, we've been loading the atmosphere with carbon dioxide. We're currently at 425 parts per million, the highest for 3 million years. And we talk about what that means a lot on the show for polar regions, for sea level rise and wildfires and all of that stuff. But what we generally don't really think about is how it might mess with fundamental processes, Penny.
Yeah, so what we're talking about here is photosynthesis, which of course is the process by which plants use light and carbon dioxide to make sugar. I think this is the most ingenious biochemical process ever invented. Would you disagree?
No, I would not.
It's super clever. It harnesses the energy and light to combine carbon dioxide and water in such a way that you produce glucose and oxygen. Oxygen is obviously helpful for those of us who breathe it. And this sugar is the building block of all carbs. And because of that, all life on land depends on the photosynthesis that is done by plants.
We're going to have another podcast about what is the most ingenious biochemical process
Stay
ever
tuned
evolved,
for that
because I'm actually starting to think we'll come back to that. But yeah, because the process uses CO2, there's been this idea that the more CO2 that goes into the atmosphere, the better plants will grow.
Yeah, up to a point. An increase in carbon dioxide concentrations can theoretically boost plant growth, but that's only for as long as carbon dioxide is the limiting factor for photosynthesis. That's not the only factor that can limit the reaction. And we're starting to learn that there's some complicated consequences of rising CO2 as well. Yeah,
so the idea that CO2 is plant food, some people have said that means there can be benefits to climate change. We could say that they are climate contrarians, or more, less politely, we could say something that, Ollie, you need to put some beeps over that. But look, lots of studies have now shown that although excess carbon dioxide does increase growth in some plants and crops, it can decrease the nutritional value of the crops. And then, of course, you get those other negative impacts like, just droughts and wildfires and stuff like that we're seeing all the time.
And so lots of studies have been done, but there's lots that we still don't know, which brings us to some work that Madeline Cuff has been reporting on for us this week about a forest in the UK where scientists have simulated what the atmosphere could be like in 2050, essentially by just pumping loads of extra carbon dioxide into the air around these trees. That's a really cool experiment, Maddie.
It's a very cool experiment, and it's the only one of its kind in the Northern Hemisphere. There are 2 underway in the world and a third being built in the Amazon. The one I went to visit is a fragment of woodland in Staffordshire, which is in the UK's West Midlands, and it's full of mainly English oak trees that are about 180 years old. And essentially the scientists there are trying to understand how this forest will cope as levels of carbon dioxide rise in the atmosphere, which is actually a really crucial question because globally the world's forests absorb around 7.6 billion tonnes of CO2 a year once you've accounted for emissions that they produce from things like forest fires and deforestation and other disturbances. And temperate forests, which are like these oak forests that we see in the UK, they are responsible for almost half of that uptake.
And the question is, can we rely on trees to keep pulling these large amounts of carbon dioxide out of the atmosphere as pollution and carbon levels increase? Will they do it better or worse than they currently do? And so then in this experiment, they're simulating 2050 levels of carbon dioxide concentrations. And if current trends continue, that will mean we're at roughly 570 parts per million. What have they found so far?
Yes, exactly. So every spring since 2017, they've fired up these machines that pump lots of CO2 around these trees, and they also have control trees to compare and contrast the responses. And they've been watching really carefully to see what happens. So we know already that with young trees that grow up in a very elevated CO2 environment, they do take up extra CO2 when it's available and they grow faster. But we didn't really know how middle-aged trees, the trees that were planted hundreds of years ago but will still be alive in 2050, how they would respond. And thankfully, the results from Staffordshire so far are quite promising. So after 7 years under these elevated CO2 conditions, the mature oak trees in Staffordshire have increased their photosynthesis rate and are producing about 11% more wood each year compared with the nearby control trees, which are living under today's atmospheric conditions. Here's Rob Mackenzie, who runs the project. He's a professor of atmospheric science at the University of Birmingham.
So the experiment that we're doing here is a very broad one about how the forest will perform in all its dimensions under this future atmosphere. But the first two things that we need to establish is there more photosynthesis happening? And we can say, yes, there is. And in fact, over the growing season, there's about 20% more photosynthesis. So about a fifth more sugar going into the system, carbon going into the system as sugar. Does that make a difference to the system? Yes, it does. We can now say, having made measurements over 8 years, that more woody material is being built up in patches like this that have the future forest atmosphere around them than in the controls that are nearby. About 10% more woody material.
So Rob said that the pleasing thing about these results so far is that they suggest that the forest isn't going to fall over, ecologically speaking, under these novel conditions. So it does suggest that these middle-aged trees do have quite a lot of adaptive capability to respond to their changing environment.
Well, the pleasing thing as a middle-aged organism is that these middle-aged trees can adapt and still thrive. What's a bit more worrying is that in experiments on younger plots in different places, ecologists have found that trees are growing faster but then dying younger. And there's this famous trade-off in ecology between growth and reproduction. And if you grow loads, you have to reproduce more slowly and also vice versa.
Yeah, I did my doctoral research on weedy plants like Arabidopsis, and it's almost like the classic opposite to being a tree. They grow really quickly, they produce loads of seeds, and they die immediately. It takes a few months with a lot of weeds. And because these plants are weedy, they're green, they grow really quick, they don't sequester carbon, they don't make wood, and their lifespans are drastically shorter than trees.
Yeah, so it boils down to live fast, die young. And a shift slightly into that direction seems to be happening in the world's forests, which means overall they might lose their ability to store carbon.
Yeah, we don't fully know yet how this fits into middle-aged trees, because there is some evidence to suggest that if a tree grows slowly while it's young, then it will likely still reach an old age, even if it is then exposed to an elevated CO2 environment. So that means our 180-year-old oak trees in Staffordshire that spent their early life in basically a pre-industrial CO2 environment, they might not be so affected by this, but it will be the trees that come later that we might see changes. What's really interesting about this giant open-air experiment is that the enhanced photosynthesis rate really does depend on the forest conditions. So Penny, you mentioned earlier that CO2 in the atmosphere isn't the only limiting factor when we're thinking about how fast trees can photosynthesize and lock in extra woody matter. And in this forest in Staffordshire that I visited, there's plenty of nutrients in the soil that are allowing the trees to unlock this extra growth. But a similar experiment, pumping CO2 out into forests, has been done in other kinds of forests. So, for example, there's one treating a middle-aged eucalyptus forest in Australia. And what the scientists there are finding is that the trees aren't locking in any extra carbon because they don't have the nutrients in the environment to take advantage of that excess CO2. So we won't see this kind of extra woody uptake in all forests around the world. It's not something to bank on.
Okay. So that's an open-air wild lab. I visited one in Sheffield last year called the David Reed Controlled Environment Facility. And there you go to like rooms where it says 600 parts per million on the door. And it's a real like, this is the future, or
Wow.
this could be an awful future. And inside the plants are growing in there at these future levels. And they're looking at how, as I said before, the nutrition of crops might change. And I spoke with Gustav Dagan. He's a photosynthesis researcher at Sheffield about how photosynthesis changes with CO2 levels. And he said you do get this initial increase in photosynthesis, like you said, Penny, with small increases in CO2, which is why we've had an initial greening of the world since the Industrial Revolution. But this is getting cancelled out.
Much of our understanding of photosynthesis under high CO2 comes from controlled greenhouse experiments. But when we look at field experiments where environmental factors cannot be controlled and nutrients in water are often limiting, we see a much smaller positive effect of elevated CO2. Another thing we observe is that over time plants often downregulate their photosynthetic machinery in response to prolonged CO2 enrichment, cancelling out any initial benefits. We also have to remember that rising atmospheric CO2 also leads to higher temperatures, which can push plants beyond their optimal growing conditions, and so counteract any positive effects on photosynthesis.
That's interesting to think that the plants adapt and they downregulate. I guess they don't want to grow quicker. They've evolved to grow at the rate that they grow.
Yeah, and that's the thing. We're messing rapidly with something that's evolved over, billions of years. And that bit about how warming also will impact growth, as well as the CO2. It reminded me of this experiment in the Rocky Mountains that started in 1991. And they literally warmed up a huge mountain meadow with electric heaters to see what would happen with warming temperatures.
These are really cool experiments, aren't they? There was those ones they did at Stanford in California where they also changed the temperature and the CO2 at the same time.
Yeah. So this Rocky Mountains one was it was the longest running climate control experiment in the wild until they yanked it a couple of years ago. And they wanted to see how the meadow would change if we're in these 2050 scenarios of warming. And it did show dramatic change in species composition. And I checked in with them. It's the Rocky Mountain Biological Laboratory in Colorado. And I talked to the former director there, Ian Billick. And, we were just been talking about the threat to science at NASA, Johns Hopkins. And here's another example of how science in America is under threat. And he said the National Science Foundation, these cuts, threaten the entire basis on which science is built in the US. And something I hadn't thought about is the undergraduate training courses that they offer.
If they proceed as planned, not only will we lose an entire generation of scientists, we're seeing rollbacks involving early career scientists, including undergraduates and graduate students. Science will be radically reduced and transformed. I suspect the total price tag of what they want to take out is something like $50 billion. One particular program that we're tracking is the Rocky Mountain Biological Lab offers one of the longest running research experience for undergraduate sites in the country. We bring out students from across the country to conduct a research project mentored with scientists. It's one of the main ways that in the United States we train undergraduates. It's unclear whether this program will be discontinued. These impacts are not going to hit just scientists, but they're going to have long-term negative impacts on economic growth. Economic growth in the United States is fundamentally driven by innovation, our ability to explore and find new ways of doing things, And that also requires a trained workforce. We will be unable to sustain our historic levels of economic growth if we really go forward with these cuts as planned. So it's very concerning for anybody, whether they're a scientist or not.
And there's 1,300 of those research experience for undergraduate programs across the US. 1,300, and they're all under threat now.
Okay, let's talk about memory. This is one of those subjects where sometimes the more you look at it, the less you seem to know.
Memory is very unreliable, isn't it?
Famously so. And that's where we're going this week. Now, if you have a strong memory for something, say imagine a headline. You've seen the headline quite a few times. It's a big news story. The understanding at the moment is that you might think, oh, that happened just the other day because it's a strong memory, and strong memories feel fresher. And often when we think, oh, yeah, that was really recently, we're then horrified to realise it was months or even years ago, right? Yeah. So that's one thing that we think about memory. But there's new research that has actually found the complete opposite, and that really familiar things we falsely think happened a lot earlier. So kind of the flip of what we were expecting. And Sophie Bodiga, you've been reporting on this for us. You're here. Tell us all about it.
Yeah, it's a really, really fascinating piece of research that's found this memory illusion that completely warps our perception of time. So the research led by Bryn Sherman at the University of Pennsylvania was actually a series of 6 experiments looking at how repeatedly seeing images affected individuals' perception of when they'd first seen that image. So in a series of experiments, they showed the individuals sequences of 250 images. So these were of single objects, so like a pineapple or a basketball. And some of those images were repeated, so some twice, some 3, some 5 times. But there were also lots that were just only shown once. And once they'd been through the whole sequence, they were then asked to place along a timeline when they'd seen those images.
I'm getting anxious you're going to test me on pineapples and basketballs.
I quite want to have a go, actually. So then was the idea that repeatedly seeing a pineapple would make your memory of it feel stronger?
Exactly. And they did find that participants had a better memory for the images that they had seen more than once. But what was really striking was that they remembered the repeated images as having appeared earlier than they had in reality. So that's, as you say, Penny, the complete opposite of what we would predict based on our current understandings of memory. And not only that, but this effect that they found, and they've dubbed it the temporal repetition effect, it's scaled with the number of repetitions. So that means that the images that were repeated 5 times seemed further back in time than the ones that were repeated 3 times, and so on.
Okay, so this is not the kind of memory that you get when you form it with an emotion. And we all know how memories sometimes can be associated with very strong emotions. And this is them trying to strip all that away and getting something to be able to look very basically at how the brain stores things. And the upshot then is that people were just bad at remembering the order in which they saw things.
Well, that was actually something that Bryn Sherman said was really surprising, because the relative ordering of the repeated items when they were recollecting it was correct. But the participants just thought that the repeated items were shown earlier in the experiment than they really had been. So this is a dissociation between the illusion and the overall ability to remember roughly when the image was in the sequence.
Okay. So in this case, the stronger memory related to something that had been experienced longer ago. And I asked Alex Easton at the University of Durham what this means about our understanding of memory. Amongst other things, he's a professor in the psychology department there. He said there's basically no such thing as memory, no single thing called memory.
Right.
But that it's made of, what we think of memory is made of many different things that happen in the brain. And the same is true when we think about time in a memory, as we've been hearing. And here he is.
It always feels like we have, in some way, time-stamped a memory, that when we think what we had for breakfast this morning or when it was, that we have some magic memory that it was 7:15 a.m. But that's not how time in memory works. There are lots of different ways we remember time. Sometimes we know it because of semantic rules about the world. We always had breakfast at 8 o'clock, so breakfast was at 8 o'clock. Sometimes we can relate it to things that we know happened. It was in my first year of high school, therefore it must have been this particular time of year. Or sometimes we might think that we do it on the basis of recency. Things that we remember well probably happened recently. Things that happened a long time ago, we probably remember less well. And what this study shows us is that's not true, that things that happened recently can be thought of as happening long ago because there's yet another way we think about time in memory. And that is by using understanding of rules about the world. Maybe in this case, lots of things happened, therefore it was long ago, something like that.
I feel like I do this, like if I'm really familiar with something, I'm like, yeah, I've been doing it for ages. Is that the same kind of thing, Sophie?
I completely agree. I actually relate a lot to this finding, and that was actually the inspiration behind it, is because Bryn and her colleagues thought, well, this isn't my experience of memory, and we want to see if this actually is a more general pattern. So that's what inspired the 6 experiments.
Okay, that's all for this week. Thanks to our guests, Maddie Cuff, Jacob Aaron and Sophie Berdugo. Thanks to you for listening.
Do tell your friends about us and give us a 5-star rating and review on Spotify, Apple Podcasts, wherever you listen. Subscribe to us on YouTube. We'll be back next week. Bye for now.
Bye.
Bye-bye.
Bye.